Hello everyone, my name is Intifada Basheer and it is wonderful to virtually join you all at the Digital Citizen Summit. So I'll be presenting my paper titled Bias in the Algorithm, Issues Raised Due to Use of Facial Recognition in India. So my paper analyzes how various commercial facial recognition tools or FRT have time and again displayed gender and racial bias and how this bias plays out when being used on Indian faces. I then examine how these tools have been used in India and look at instances of inaccuracy and bias and how they have led to poor outcomes when deployed by law enforcement agencies. Lastly, I explore some debiasing measures. So without further ado, let's get to it. First things first, how does a machine recognize a face? Very simply put, the technology is trained on vast data sets to learn how to match a face that it sees on an image or a video with a pre-existing database. So there are three steps to this process: face detection, feature extraction, and classification. So first, the software tries to detect a face from whatever visual material is provided to it. Once it detects the face, it creates a unique feature, number space template for that face. And then it does one of two things. That is, it either identifies the face or it verifies the face. So what do I mean by this? Identification is when it uses the template that it has created and it tries to match it with n number of templates that are already present in its database. Verification, on the other hand, is when it uses the template that it has created to match, to see if it exactly matches another particular template that it has in its database. Some examples of verification include when you use the technology to unlock your phone. And for identification, we can say when police forces use CCTV cameras and face recognition technology to identify criminals. So now, how do we understand bias in a technology? So bias in FRT can be understood as when the system displays different error rates when being tested on different groups. So now these groups can either be categorized based on race, gender, age, and so on and so forth. Before we move on, I would also like to highlight the two types of errors that are possible when a system misidentifies a face. So there's false positives and false negatives. False positives refers to when the system identifies two different faces as one, and false negatives refers to when the system fails to match two images of the same face. So here are some studies that have been conducted in the US that have extensively looked at racial and gender bias in commercial softwares that are popularly used in the US and Europe. The first study, which was conducted by the American Civil Liberties Union in 2018, examined Amazon's FRT, which is called recognition. Now, it used 25,000 publicly available arrest photos or photos of criminals, and it ran this database against the photos of all sitting members of the US Congress in 2018. Now, what it found was that the tool misidentified 28 members of the Congress and matched their photos against the photos of criminals present in the database. Now, of these 28 mismatches that occurred, 40% were people of color, and this is highly disproportionate because only 20% of the US Congress constitute people of color. The second study, conducted by the National Institute of Standards and Technology in 2019, it reviewed 189 algorithms developed by 99 developers on a database containing 18.27 million images of 8.49 million people. Now, what the study found, it tried to identify how these algorithms perform on two tasks, that is verification and identification. And what it found was that there were higher false positives of Asians and African American faces. And the last study, which has been a breakthrough study of sorts, called the Gender Shades Project, which was conducted by MIT's Media Lab in 2020. examined three commercial FRT tools developed by Microsoft, IBM, and a Chinese company called Face++. And it found that, again, all three of them were biased against darker skinned women. Now, what's interesting to note is that the overall accuracy rates range from 87.9% to 93.7%, which are quite high. But then when you look at the accuracy rates for male subjects and female subjects, that's when the disparity really comes into the picture. So one of these algorithms, the Face++ algorithm, produced an accuracy rate of 99.3% when tested on male subjects. But then the error rates for female subjects ranged all the way from 8.1% to 20.6%, which is very high. And if you can see the image on your screen below, it shows how one of these algorithms misidentified many famous Black women, including Oprah Winfrey, Michelle Obama, and Serena Williams, and misidentified them as male. When compared to the US, there is a paucity of such FRT studies conducted in India, especially the ones that were tested on Indian faces. However, there's this audit that was published by the Digital Governance Network, which is quite relevant to our discussion here. The audit tested 4 commercially used FRT tools in India, including the ones developed by Amazon, Microsoft, one by a Chinese company called Megvii, and another by an Indian company called FaceX. Now, what found out was that the overall error rates were quite low. That is, the error rates when these tools were tested on both male and female subjects. However, the error rates were quite high when these tools were exclusively tested on female subjects, and they even went up as high as 14.68%. And what's interesting is that the Indian-based FaceX tool also recorded a very high error rate of 10.47%, which was much worse than its US counterparts, the tools developed by Amazon and Microsoft. Now, moving on to the deployment of these tools in India, they have been used by various private as well as government agencies, including the Indian Railways, at airports for the DigiYatra scheme, and for city surveillance projects that are quite rampant and well known in metro cities such as Hyderabad and Delhi. According to the Internet Freedom Foundation, 169 FRT systems are currently in use across the length and breadth of the country. Now, a lot of objections have been raised to the use of these tools by government agencies with regards to issues of privacy, infringement of rights, surveillance, and so on. While it's beyond the scope of my paper to extensively look at all those different facets, I would like to bring your attention to how bias and inaccuracy of these systems have caused concerns lately. In the first case, which is the identification of missing children in 2019, it was found that the FRT tool used by the Delhi police matched pictures of missing boys with that of girls. And in fact, what's highly concerning is that the percentage of children that were correctly matched was less than 1%. The second case is that of the farmers' protests at the Red Fort in 2021. The Delhi police used FRT systems to identify protesters. While that in itself is a completely different issue with regards to infringement of rights, what I would like to highlight here is that how an accuracy of 80% was used for positive matches. And matches with, and even more concerningly, was that matches with less than 80% similarity were also used for investigation. And the Delhi police said that in such cases, they would use corroborative evidence to pursue those cases. Now, an 80% accuracy is quite low. And why did the police force use that threshold? How did it come to that conclusion? And what were the data sets on which the tool that they used were trained, and how accurate they were? All of that is not transparent and not available to the public, which is again very concerning. Now, what is the way forward and how can we debias these tools? The most common and highly emphasized solution is to have balanced data sets that are representative of minority communities as well as marginalized groups. The second being is AI in context. Many researchers believe that technologically debiasing data sets isn't enough. Developers should also be mindful of whom these tools are meant to benefit and look at preempting ways of removing potential biases. Next, transparency on how these tools have been developed and on what kinds of data is important, along with regular audits by independent agencies to ensure that these tools are accurate. Lastly, we need a strong FRT regulation in the country.